We just defined the determinant and derived its properties, and we came up with 10 properties. First three properties define the determinant. Then we derive 4 through 10 from those three. You could derive, I guess, an 11th. If you put properties 3 and 4 together, it means that if any two rows or columns of a matrix are just scalar multiples of each other, the determinant is 0. That's because you could multiply one of those rows by a constant to make it equal to the other, and then you have that constant times a matrix that has 2 equal rows, and that determinant is 0. So you can kind of consider that as the 11th property. So let me get into applying these properties. One big thing is you can now calculate a determinant just from the properties. Say you had this guy. If you can use elimination to get it into a triangular form, in effect row echelon form, then you can calculate the determinant. And if you do it carefully, the only thing that might change is a sign when you swap rows. When you just add a multiple of one row to another, it doesn't change the determinant, right? That's one of the properties. So if I go through this, first I'll swap the first 2 rows, so I get a minus sign here. Then I do elimination. Let's see, I'm going to subtract twice row 1 from row 2 and 5 times row 1 from row 3. I get this. Do stuff one more time and you get this. Now it's triangular. I can multiply the diagonal terms. I get minus 11. I calculated the determinant just from the properties and doing some elimination steps. If you did all those and you got a row of all zeros, then the determinant is 0. And otherwise, as long as you avoid multiplying any row by a constant, the determinant is going to be within a sign the product of the pivots of the resulting matrix in row echelon form. It'll be a plus if the number of row swaps is even, and a minus if the number of row swaps is Say A is 4 by 4, and you know the determinant of A is the number 5. What's the determinant of this guy? 3 times A transpose. Well, the transpose part doesn't matter because the determinant of a transpose is the same. So that part is the same. When you multiply a whole matrix by a number, you're multiplying each and every row of that matrix by a number. And every time you multiply a row by a number, you multiply the determinant by it. So in this case, I've got a 4 by 4. I'm going to multiply, and I'm multiplying by 3. That's multiplying by 3 4 times. Now you can do the arithmetic. And in general, you get this. If you multiply a matrix by a constant, the determinant of that thing is not just k times the determinant, it's k to the n, where a is n by n. And then it's sort of 12th property. Now let's do a couple of examples. Say here we have an original determinant that's given to us. Find the determinant of these two guys. Let's see. What happened here? Oh, I switched columns 1 and 3. That's one exchange. It can work on columns. So therefore, the determinant of A is just minus 5. What about B? What happened here? Well, let's see. I multiplied the first column of the original by 2, and then multiplied the resulting second row of the resulting matrix by 3. So I have two operations where I multiply. One multiplied by 2, the other multiplied by 3. So the result's going to be 30. 2 times 3 times 5. Here's the actual what happened in each step of that. Takes a little creativity to try to reverse engineer what happened. Let's see, what about this guy? Well, I could subtract this first column from both of these second columns. And I just get this. And now I have two columns that are equal, so the determinant is 0. What about this guy? If I add the second row to the third row, I get this. Oh, I get it. We'll call that B. So the determinant of A equals whatever the determinant of B is. But either this bottom row is all zeros, in which case the determinant is 0, or it's just a multiple of this first row, in which case the determinant is 0. So the determinant is 0. Okay, I'll stop there because from after this, we're going to derive other ways to calculate determinants other than using elimination and get it into triangular form.